Hello, dear students. I welcome you all on this virtual platform. Let me introduce myself. I'm Dr. Yogesh Zorapur, working as Assistant Professor in the Department of Chemistry at this prestigious Pratibha College of Commerce and Computer Studies, Chinswad, Pune. Chemistry of nanomaterials is highly relevant as far as nanoscience and nanotechnology is concerned. You all familiar with the word nanotechnology, and recently you all hear this word very frequently in every national and international conferences. Nanotechnology is a technology based on size. They are materials obtained from bulk material. Bulk materials, when converted to nanomaterials, we can observe sudden variation in its physical as well as chemical properties. The nanomaterial science offers some interdisciplinary aspects as well. That is, nanotechnology has its roots in science, its application in different areas of science. Thus, this add-on course on synthesis of nanomaterials and their characterization using instrumental techniques is a highly relevant course. Thank you. I'm very delighted to have you all for this add-on course, and I'm very thankful to all the participants from various colleges for showing an active interest in joining this course on instrumental techniques for characterization of nanomaterials. Basically, my sessions are divided into two parts. In the first part, we will have the introduction of nanotechnology, history, importance, nanomaterials with examples, different shapes for noble metal nanocrystals, nanomaterials, characteristics and preparation, and in the end we will see the characterization of nanomaterials. In the second part, we will discuss in detail the IR spectroscopy, like principal IR instrumentation, how actually IR plot spectrum looks like, peaks classification, and then characteristics, and in the end we will see the various applications of IR spectroscopy. So let's start with the introduction. So as you know, the nanotechnology, that is nano word, that means dwarf. Dwarf means it is a small size, okay, or smaller size than the normal what we observe in nature, okay. So nano, usually it is the 10 to the power minus 9 or billion part of 1 meter. The term nanotechnology was first defined by Japanese scientist, that is a well-known scientist Taniguchi of the Tokyo Science University in 1974. It is generally used for the material of size between 1 to 100 nanometer. So basically whenever we discuss about the nanomaterials, so those all are between 1 to 100 nanometer in size, okay, and those all particles are known as nanoparticles or nanomaterials. In nanotechnology, a particle is a small object, that means as a unit with respect to its transport and properties. Okay, let's move to the next slide to have the detail. So before moving that, so what is the size? So size, when we talk about the nano, so we all know that is a deca, that is a it is 10, and then hecto is 100 and kilo is 1000. So similarly we have that tera, peta, exa, those are in a very large size, that is a macro size, okay. And when we talk about the nano, we have to go to the smaller size, okay. So when we move from the 1/10 of 10, that is your 10 to the power minus 1, that is deci. And when we talk about the centi, that is 1/100, that is 10 to the power minus 2. Similarly we have the nano, that is 10 to the power minus 9, And then the more smaller size is, that is a pico. Those are very rare materials. That's the reason we are restricted to nanoparticles and nano size, that is 10 to the power minus 9. And this is the well-known scientist, that is Taniguchi, with the structure of nanoparticles, that is carbon nanotube model. So let's move to the history. Before going detail about the nanotechnology and the synthesis and the characterization, so basically we should know the history, how the nanomaterials and nanoparticles, they have been developed and how they have presently been recognized. The first ever concept was presented in 1959 by the famous professor of physics, that is Dr. Richard Feynman, and he got a Nobel Prize for his invention. The invention of the scanning tunneling microscope in 1981 and the discovery of the Fullerene 360 in 1985 led to the emergence of a nanotechnology. So basically, in the year 1981 and in the year 1985, those were the crucial, that is the 80s, we have the major invention that has led to the recent technology, that is a new technologies, or we call a super technology, that is a nanotechnology. And the term nanotechnology was coined by Professor Taniguchi in 1974. So when we see the history of nanotechnology, so basically in the year like many years back, sulfide nanocrystals used by Greeks and Romans to dye hair. Okay, so thousands of years back there were nanocrystals, but nobody was knowing about their structure and their application. Okay, so in the year 1000, that is a gold nanoparticles of different sizes used to produce different colors in stained glass windows. So the color glass windows what we see now, so those were in the earlier also, and that concept was of the nanocrystals. And in 1959, Richard Feynman, so he basically has some idea about how the size matters and how the size helps in having the various application. There's a plan, so that's the reason he quoted a very famous quote, that is there's a plenty of room at the bottom. And this quote now it's the reality, because nanomaterial and nanotechnology is having the numerous application in various fields. So in the 1974, the first molecular electronic device patent was been submitted, and in 1981 then IBM, one of the multinational company that invented the scanning probe microscope, and in 1981 Drexel published molecular engineering, that is molecular machinery. And similarly then several scientists and various multinational companies, they have been working on doing some new inventions in the field of nanotechnology. And in 1991, the discovery of carbon nanotube, this is one of the very important discovery, and it leads to many applications in the field of nanotechnology. So that was by Sumi Ijima at NEC Research Lab, that is one of the Japanese company. In the 1993, the first US research lab devoted entirely to nanoscience. So that was the people started recognizing that how important this nanoscience and how it can be applicable to various fields. So that was the first research lab in US. In 2000, US launched National Nanotechnology Initiative, and this is one of the very important decision by US government, and that leads to present nanotechnology research, or we can say the nanotechnology R&D. And in the year 2003, the President Bush signed the Nanotechnology R&D Act, that is of $3.7 billion over 4 years. So that was a big investment that was been signed by the President Bush in 2003. So basically, what is nanotechnology? So like we are hearing like nanotechnology, nano. So what is exactly? So according to the global market report, nanotechnology will exceed 1.25 billion dollar in next 5 years from now. So if we see this technology is going to garner such a big market share, it must have something special in it, and it's none other than its application. So basically, because of the application, it has really it can capture all the technologies those were in the last century. So the design, characterization and application of structures, devices and systems by controlled manipulation of size and shape of material at the nanometer scale, and that is the nothing but a nanotechnology. So to produce such type of materials, we need a special characteristic feature of that particular material, and that is what the size of 1000 millionth of a meter. So people are interested in the nano scale because at this scale, physical and chemical properties of materials that drastically differed. Actually, the raw material what used in the preparation of the nanomaterials and the materials what we synthesize, so they drastically change from the beginning till the end, and that gives a special characteristics to that material, and that material is what we call it the nanotechnology. So there are various materials that we see, and they have the different sizes, and when we talk about the size of the item, it is 0.1 nanometer, that is 10 to the power minus 1. And when we move to the DNA, that is a DNA, that is diribonucleic acid, deoxyribonucleic acid, and then RNA. So these are all the polymers, long chain polymers with base and then carbohydrates. So that is having a 1 nanometer size. And then we move to the most larger, that is a quaternary structure of the protein, and that is having a 10 nanometer size. And similarly we go on then to the larger sizes, that is a red blood cell, and it is having a micrometer, so it is less than the nanometer. And then our hair diameter is having 150 micrometer, so it will be approximately 0.1 nanometer size. Okay, so and then we go on till that is a grain of sand, so it is approximately 10 to the power 6 nanometer. Okay, so these are the various example we can see. They have different sizes, and that are available in nature.